All right, so here's what we're doing today. We're going to do 8.3 out of the book. It's solving equations involving square roots. And then just a reminder, our exam one, our first exam, is 2 weeks from today. We will review the day prior to that. So next week, we still have new material. The week after, we review and then test. All right? Okay, now questions over homework. Yes. 51, was this from 8.2? Okay, number 51. All right. Number 51. Let me make sure I'm doing the right one here. It's 2 root 12 plus 7. 2 root 12 minus 7. Is that the one? Okay. So because you're multiplying, you have two sets of parentheses. You have two terms in each set of parentheses. You have to do like that foiling thing that we did last class. So you have to start by taking the 2 root 12 here, multiplying it over times the 2 root 12 here. Right? That's your first multiplication. So I'm just going to write that down. I'm taking 2 root 12. I'm multiplying it times 2 root 12 again. That's your first thing, right? Now I do the exact same thing. I take my 2 root 12. This time I multiply it times whatever's back here. And make sure you pick up that sign on there, right? It's negative 7, right? So I'm doing, what's it going to be, a positive or a negative number? It's going to be negative because I have, the first term is a 2 root 12, which is positive, times a negative 7, that's negative, times this, what do you, okay. Where you're negative. Okay, so look at this. This right here in front of the 2 root 12 is really like a positive 1, right? It's a positive number. 2 is positive, root 12 is positive. And then over here, your 7, that's a negative 7. So when you multiply a positive times a negative, you get a negative, right? If you multiply two numbers that have opposite signs, it's negative. So that's why I'm going to put a minus 2 root 12 times 7, right? You see where that sign comes from? From the negative. Now, when we do the inner multiplication, that means I'm going to take the positive 7 and multiply it over here times this. They're both positive, so positive times positive is positive, right? So that's why I'm going to do now a plus 7 times 2 root 12. And then my last multiplication is going to be the positive 7 times the what? Negative 7. Right? Positive times negative is negative. So it's negative 7 times 7, which is 49. Does that help clarify where your signs come from? Okay. Now let's go ahead and just finish this off. The first one, you're going to get 4 because you put 2 times 2. And then root 12 times 12 is 144. So I put the root 12s together, which the square root of 24 is going to turn out to be, square root of 12, square root of 144 is going to turn out to be 12, but I'll do that next step. Minus 14 root 12 plus 14 root 12 minus 49. Is that all right? Now let's just real quick look at the middle terms. The middle terms here have the same square root, right? Root 12, root 12. They're being added together. So you're supposed to look at the numbers in front and put those together. So what's negative 14 plus 14? 0. It's gone. Yep, they're gone. So these wipe each other out. So these are gone. And then back to that first term, this is really 4 times 12. And then at the very end, we had minus 49. So Square root of 144 is 12. And 4 times 12 is 48. Minus 49 is equal to negative 1. That all makes sense now? Kind of? Any others from the homework? Okay, let me look at that one real quick. Root 2 minus root 3 times root 10 plus root 15. And this was number 47. Okay, so I'm going to do the exact same thing. This time I'll go a little bit quicker. Square root of 2 times the square root of 10. I'm just going to write that down. Root 2 times root 10. Then I'm going to do root 2 times root 15. Now, is that going to be positive or negative? Am I going to say plus or minus that? Plus, because they're both positive. So plus root 2 times root 15. Then I'm going to do the inside ones. Root 3 times root 10, but is it going to be positive or negative? Negative, because I'm doing a negative times a positive. So minus root 3 times root 10. And then my last multiplication, positive or negative? Negative again. Root 3 times root 15. Now, I like to just put all these together. Root 20 plus root 30 minus root 30 minus root 45. So how did I put those together? You multiplied what's underneath. Now, the reason you can put those two together and create this is because there's multiplication between them. I saw on a lot of the quizzes, I saw people putting things together like that when it was addition between them. For example, like on the quizzes, I would see this. Root 2 plus root 10, and you would say something like root 20, or maybe you'd say like root 12. Those are both incorrect. You cannot put those two roots together, right, over here, because they're not exactly the same underneath the roots. If it's multiplication, then you can put them together, and you multiply what's inside. All right? These become this. All right. This is this. So on and so forth. Now, do you see something good here? Do you see anything good that happens? The root 30s cancel each other out. That's good, because I don't have to worry about that now. And now what I need to do is break down these other two roots, 20 and 45. So this is where I would come over here, and maybe I'd write down 20. I try and think of 20 as being something times something, with one of them being a perfect square. 4 and 5. So this becomes root 4 times 5. I'm showing more detail than I have normally shown at this point. Right? I rewrote 20 as 4 times 5. I broke 4 times 5 back up into two square roots. The square root of 4 is 2. The square root of 5 is just square root of 5. So I haven't done anything to the square root 5. That okay? Now I have minus. Now let me go break my 45 down. 45 is what times what? 9 and 5, right? That's a good number to pick, 9, because it's a perfect square. So this breaks down to be 9 times 5. Minus, so square root of 9 times square root of 5, which is 3 root 5, right? And are we done? You can actually subtract these because they have the same exact thing underneath the square root, right? They both have 5. And so you're saying, like, 2 apples take away 3 apples, which leaves you with how many? You're taking 2, subtracting 3, minus 1. Minus 1 root 5. Or you could just write negative root 5. Either way. I believe so, yes. I'll have to look at it. Yeah. Yeah. Okay. We're going to go ahead and start with today's material. And today's material, to start off, I said we're going to do solving equations, right? We're solving equations with square roots in them. And the first thing we need before we start this is what's called the squaring property. Okay, the squaring property. Squaring property says this: if two things are equal to each other, if you have an equation where the left side equals the right side, A equals B, then this is always true. A squared will equal B squared. So essentially, if you square both sides, we squared both sides of the equation, that new equation, after you square both sides, will also be equal. So we need that. This just tells us that anytime we have an equation, we're allowed to square both sides of the equation, if we need to. Well, you know how we learned with equations, you can, like let's say you have something like x plus 2 equals 4. And you were taught, okay, if you have an equation like that, you can subtract 2 on both sides, right? You were told at some point you can always subtract something on both sides, or you could add something on both sides. Or you're told if you have a problem like this, 3x equals 6. To get x, you can always divide both sides by anything except 0. You can never divide by 0. But those are properties of equations. You can add and subtract on both sides, or multiply and divide on both sides. This is a new property. It says if you have an equation, you can square both sides. So it's different than multiplication, it's different than division, it's different than addition and subtractions. It's squaring. So now let's see how we can use this to solve an equation. All right. After we do one example, I'm going to give you a set of steps. So we'll start with the very basic example. What if I say this? The square root of some number equals 2. Can anybody just look at that and tell me what the answer is? 4, right? Because the square root of 4 is 2. But let's act like we couldn't tell that the square root of 4 is 2. How could I get the answer? Like how could I solve for x here? I square it. And the reason why I square it is because when you have the square root of x, and you take that side of the equation and square it, then you take the other side of the equation too and you square it, something good happens on the left side. What happens when you square a square root? It goes away. Now, why does it go away? I mean, we're not going to need to know this, like in general, we're not going to need to know this, but let's talk about why it goes away. Squaring something means multiplying it times itself, doesn't it? That's what it meant to square. And doesn't this become, we can put it back underneath one root and do this? The left side. And whenever we have the square root of x squared, didn't we say how many times does 2 go into, in this case, what? How many times does 2 go into 2? 1 time. With how many left over? None, right? So that means that this would turn into just to a single x. And then the right side of the equation becomes what? 4. Okay, now this part right here, we don't need to show that. Okay, you don't need to show that every time. All you need to know is that when you have a square root and you square it, the root goes away. And what's left is what was underneath it. So that gives us our answer, right? Which is what we wanted. That's just a real simple introduction to squaring both sides. Now let's actually write down a process. How to solve equations with square roots. In 2 weeks, you're going to have an exam, and you're going to walk in here with the cheat sheet, right, that I'm going to allow you to have on that exam with formulas and steps and procedures. This is a set of steps that I would recommend you have. Along with that other one that we use for rational equations, excluded values, LCD, remember that? Okay, here's another set of steps. So the first thing you're going to do when you're looking at a square root equation is you're going to isolate the square root. What we mean by isolating the square root is basically get the square root by itself on one side of the equation. We want it to be by itself on one side, either the left or the right side of the equation. It doesn't matter. We just want it by itself. That's the first step. Second step, square both sides. Why do you think we would square both sides after we get the square root by itself? Yeah, what I do to one, I do the other. But if one side has the square root by itself, then when I square it, it'll go away, right? So it'll be whatever was under it. That's a good thing. That's why we do it. But you have to isolate that root first. Okay, step 3 is a little weird. If you still have any square roots, then repeat steps 1 and 2. The hardest problem we're going to do today will be where we have to do step 3 here, where we go ahead and isolate the root, then we square both sides, and after we do that, we look at the problem, we say, crap, we still have a square root, and we have to repeat the process. That'll be the last problem that we do, like the last type. And then step 4, we will solve the remaining equation. And then step 5, check your answers. I was talking to a friend of mine this weekend who's a physician assistant. Do y'all know what that is? It's like a doctor's helper. Basically, when you go to the doctor, you usually see the PA. What's that?
So when you see a doctor,
Mm-hmm.
the doctor has to see a PA.
Mm-hmm.
So you're paying out for the amount that you have to see the doctor.
Yeah.
You
Yeah.
really just
The PA is basically the doctor's assistant, basically. Okay. So anyway, he's a friend of mine is a PA, right? And for some reason, he got through all. He's a PA, but he does not have a college degree. It's complicated. It's some grandfathered clause from when he lived in Wisconsin. Go ahead, sharpen away. So he doesn't have a college degree, but he wants to finish up his degree. He only needs college algebra. That's all he needs, and he'll have his degree. So we were talking this weekend about, why would someone who's already professional need college algebra? And it brings me back to well, why do you even need this, right? And this is a perfect example of what I tell everyone when it comes to why do you have to learn math? This is all about, you're never going to be faced, whatever job you get, I doubt it, you'll ever have to solve an equation with a square root. Unless you do teach math at some point. So why is it important for you to learn how to solve an equation with square root? It's really, can you follow a process? Can you or not? I'm giving you a process here, right? Set of steps. and they're very logical. They're very rational. It's this, then this, then this, then this. Math is all about structure. You can do this. You can't do this. There's rules. So by finishing a degree and having college algebra checked off in that degree completion box, it just says that you have demonstrated a certain skill set, right? And just like you take English or something like that, composition, what does that say? That you're a master poet or that you're a master writer? No. It just says that you have basic writing skills, right? Then you take some electives, art. That just shows what you've learned a little about art. You know a little bit about composition, whatever it is. So college is about producing someone who is, I guess, well-rounded. You've demonstrated certain abilities. And so when someone hires you, they know you've demonstrated that. I don't know if that makes sense, but so in Math 0303, we are looking at a 5-step process. In college algebra, you'll be looking at 15-step processes where you have a problem that requires that much work. But it's not about what you're doing, it's about can you follow the procedure. So let's focus on procedure. That's why I told you on that one test, remember the first quiz we took, take home? I want to see procedure. I don't care if you can get the answer, show me procedure. All right, let's do this. Isolate the root, blah, blah, blah. Here's your first example of this method. So let's do 4 plus the square root 11 minus x equals 16. Now, when you're looking at this, you have to know what you're looking at. Like, think about this as you're sitting there at the test, right, in 2 weeks from today. Is this a rational equation? Remember, we did rational equations when we started this class. Rational equations were fractions, right, where your x's were in the bottom, and that's when we did excluded values, LCD, right, all that. Is this rational? No. Is it a square root equation? That's the only other type of thing we've done, right? Yes, it's square root equation. The key to that tips you off, it's square root. So you have to know this going into the test. I'm not going to prompt you. I'm not going to say, hey, use this technique to solve this. I'm going to say solve. That's it. Solve. I forgot to put that here. Solve. Okay, so it is a square root equation, right? The first step to solving a square root equation is to isolate the root. So I'm going to isolate right now. To isolate the root means I need to get the square root and everything underneath it by itself, right? On one side of the equation. Right now, there is a 4 that lives on the left side, and I don't want it there. So how can you get rid of the 4 that's on the left? Subtract, right? Not divide, because it's addition between those two things, so subtract 4. So I'm going to take my 4 plus square root 11 minus x equals 16. I'm subtracting 4 on both sides. I can subtract 4 from 16. I'll be left with 11 minus x equals what? 12. All right, would you say that we have isolated the root? Is it by itself? Yes? Yeah, it's by itself. So what's the second step then? Square both sides of the equation. So now what I'm going to do is I'm going to take my equation right here, and I'm going to square both sides. So I square the left, and I square the right. Now, when I square the left, because I have a square root and I'm squaring it, they just kill each other off, right? But what's left? What will still be there? If the square kills off the square root, the whole thing that's underneath, the entire radicand is left, which is what here? 11 minus x. The whole thing needs to be written down. 11 minus x.
So then when you square, what is the right this way?
Because I'm squaring it, because of this squared, and because I have a square root, those two things wipe each other out. The first one says take the square root. The second one says square it. So basically it's a wash. Nothing happens. And what's underneath is the only thing that's the result. Whatever was underneath is basically unaffected. And then on the right side, equals 144. Be careful, that's squaring, right? Not multiplication. So it's not 24, it's 144. Now this equation, what we have left here is a linear equation. But we need to go to step 3. What's step 3? Yeah, do we have any square roots? We have no square roots left. And because of that, I go to step 4. So step 4 would be what? Solve the remaining equation. So I look at this equation that I'm left with. This is, like I just said, this is a linear equation that I would expect everyone here to be masters of. Subtract 11, both sides. So you have negative x equals 133, right? And then how do I get x by itself here? Divide by negative 1 or multiply by negative 1. All it does is changes the signs on both sides. And now I have a potential solution here, don't I? X equals negative 133. The last step is to check the answer. So when I check this answer, I'm going to write down the original problem. The original problem. The way it was presented to me when I started. And what I'm going to do is I'm going to replace my x with negative 133, and I'm going to see if this checks out or not. Ready? Be careful with your parentheses there, or be careful with your signs because you're doing 11, take away a negative. It's going to make it a positive. Mm-hmm. Yes, back into your original equation. Yep. Always go back to the original, though. So we have here 4 plus square root. This becomes 144 underneath because you're doing 11 plus 133. What is the square root of 144? 12. What is the left side? 16. Is 16 equal to 16? Yes. See, we're checking this. We're making sure that when we plug what we said the answer is into the original problem, it checks out. It makes the equality true. So what's the answer to the problem? X equals negative 133. That's the solution. But these are the steps required to determine that. Okay, I'd like for you to try a couple of these, okay? I want to see how you do with this. You can work together on it. I'll come around and see how you're doing. So how about you try and, on all of these, solve. Let's go square root x minus 2 equals 6. Five plus square root 3 minus x equals 8. Third one, square root 6y plus 5 equals 0. All right, go ahead. I'm going to pause the video. Okay, so for this last one, I'm going to subtract 5 on both sides. And that'll give me root 6y equals negative 5. A lot of people are okay getting up to that point. Square both sides. Squaring the left side just gives me 6y. Be careful on the squaring of the right side. Doesn't matter if it's positive or negative. When you square something, the answer is positive. So we should get 25 over here. And now to get y by itself, I'm going to divide by 6. And that number cannot be reduced, right? That's just a fraction. Okay, so far this is what I think the answer is. But when I check it, I go back to the original equation that was given to me in the very beginning, right? It was this. And I'm going to replace my y with 25 over 6. So here it comes, 25 over 6, and that's being multiplied. And then I have over here plus 5, equals 0. Now, so I'm asking, is this true? Well, the 6 here and the 6 here cancel, which gives me a square root of 25 plus 5 equals 0. The square root of 25 is 5. And so what I'm saying is 5 plus 5 is 0. And that's not true. Everyone follow that? So what this means is that the original problem, which is here in yellow, there is no number that you can plug in to make that equation true. So it has no solution. And we talked about this back in the beginning of class, like earlier in the semester. I said, when you have equations, you basically have a couple of possibilities. You either have an answer, or you have no answer, or you have infinite number of answers. In this case, we have no answer, no solution. So how do we write no solution? There's a couple of ways. No solution. I'll accept that. Or you can do, the set of braces is usually where we put the number in there for an answer. But if you leave it blank, that means that your answer is nothing. Does that make sense? But the answer I like, that I prefer, is this right here. This is called the empty set. All the empty set is basically the set of nothing. Now don't confuse that with the number 0. It's not the number 0, right? Anybody military has ever done a 0 by writing 0 with a line through it? No military here that never did it? Well, the 0 with the line through it is so you don't confuse it with an O. But that's military. In mathematics, that does not represent the number 0. It represents the set of nothing. So think of it this way. Maybe this will help you. Let's say you have an answer. Let's say you did a problem and you said the answer was 2. Imagine having a bucket, and inside that bucket, right, is the number 2 sitting in there all happy, right? Then the way I'd write that is the set, that's the set of braces. That set 2 means that 2 is in that bucket, right? Kind of make sense? When I write this empty set, I'm basically saying your answer is the set of nothing, which means there's nothing in the bucket. It's an empty bucket. Okay? All right. Now, the problems we did so far have been easy because we isolated the root, no problem. Squared both sides, no problem. What remained was a linear equation, which was not really a problem. So let's start to turn it up a little bit here, see if we can handle something a little more challenging. How about if we have something like this? Square root of x squared minus 3x minus square root of negative 10x minus 12 equals 0. Now that's starting to look pretty ugly, isn't it? Mm-hmm. That's the great thing. It's the same steps. But what's wrong with this compared to what we've done before? What do you see as a major difference in this problem? I have two square roots, right? I have two of them. So my first step is always to isolate the square root, but there's two of them. So which one do you isolate? Turns out that it doesn't matter. Just pick one and isolate it. So I'm going to pick this one to isolate, which means I have to take the other square root and take it to the other side of the equation, don't I? How do I get that other thing to the other side? I add the whole thing on both sides. So I add, I add the square root of negative 10x minus 12 on both sides. The square roots cancel on the left side. And so my new equation looks like this. Square root x squared minus 3x equals positive, so I'll just put the root, negative 10x minus 12. Now this is step one, okay? That was step one, that was isolate. And I could already tell when I walked around that there were a lot of you that were doing the problem but weren't writing down the steps. And I'm just warning you, college algebra, 15-step problem, you're not gonna make it. Okay, you've got to get the steps down. All right, you've got to start getting used to organizing your thoughts and putting them on paper. Yes.
So why did you add square root negative 10x minus 12?
Mm-hmm.
And then you did it again to the right, you just brought down the same.
Well, let's imagine that this whole thing right here was the number 5. Okay, that whole big square root was 5, right? So it said, what's in yellow? Minus 5. Wouldn't you add 5 to both sides? That's exactly what I did, but it's not 5, it's the whole root. So I had to add the root to both sides to make it cancel on the left and appear on the right. I mean, it has to appear on the right, because what you do to one side, you have to do the other.
So why couldn't you just brought down negative 10x minus 12?
Why couldn't have I?
You just popped it under in the square root, you just brought it down.
Are you saying why did I use the square root also, not just?
Okay, where you just want the number 5,
Mm-hmm.
10x minus 12.
Yes.
That part right there, to me, all you did was just bring it down.
No, I added 5 here and added 5 here to make these cancel.
Okay, then what you got here, that's negative 10x minus 12, is the same thing that we're doing.
But it's on the other side of the equation, right? In the original equation, they were both on the left side. One was being subtracted. Now what I did is the 0 that used to be on the right now has that whole square root there. You okay with it? Okay. Now, have we isolated the square root that we wanted to? Yes. Now you square both sides. So this is step 2. Okay, so I'm going to write it all again. All right. I'm going to just write the whole thing again. Whatever I do to the left side, I have to do to the right side, so I'm going to square the right side also. Is that okay, just squaring both sides? Now, we actually have some really good stuff happen here. The left side, the square root goes away, doesn't it? Yes? Because we're squaring a square root. But look at the right side. What happens on the right side? Same thing. We square a square root. So both roots go away on both sides, which is fantastic because, as you'll see in the next couple of problems, it doesn't always work out that nice. So both roots go away. So my left side is just whatever was underneath, which we call the radicand. And the right side is just the radicand here, so it's that.
So when you did
What's step 3? Yeah, repeat it if you see a square root. Now, we don't have any square roots, thank goodness, right? So no square root. So we'll go to step 4. And what is step 4? Solve the remaining equation. Yay. What type of equation is this? Because it's not linear. Linear is what we had before. It's quadratic. And we've already talked about everyone in here needs to already be comfortable with solving quadratic equations. So the process for solving a quadratic equation, right, because that's what we have, quadratic equation. The process for solving quadratic equation, hopefully you learned it in 0302, is to get everything to one side first, right? Set it equal to 0. So what I'll do here is I will add 10x on both sides, and I will add 12 to both sides. And in doing this, my right side becomes 0, and my left side becomes what? X squared plus 7x plus 12. Now we have a quadratic equation in a standard form. You can either factor it, or you can use AC method, right? You can do guess and check. You can do quadratic equation, or sorry, quadratic formula. So the question becomes, can you factor that? Well, I'm going to have to assume that you can, because that's part of a prereq for this class. But again, I'll put my star here. If you don't know how to do that, I'm going to keep saying it, you've got to know how to factor. So, somehow you got to get from here to here. And I'm willing to help you. The lab's willing to help you, but you've got to get that method. Once you're here, what do you do once you're here? So that's right. Set each factor equal to 0. So you take your x plus 3, set it to 0. You take your x plus 4 and set it equal to 0. And then solve these two equations. Those are both what we call little miniature linear equations. You just subtract 3 and subtract 4, and you get two answers. -3 and -4. Now that was step 4, right? We still have a 5th step, don't we? The 5th step is to check our answers. Jeez. Okay, 5th step, check. So let me first start by checking this answer, -3. I take -3 and I plug it into the original problem. Now I'm going to write the original problem up here just so we have it on screen. It was x squared minus 3x minus square root -10x minus 12 equals 0. That was the original problem. I now need to check it by replacing all my x's with what? -3. So let me see what happens here. I'm going to have -3 squared minus 3 times -3 minus square root -10 times -3 minus 12. Does that equal 0? Do y'all see all my x's here? Got all replaced by -3's, right? What's -3 squared? 9. So we got square root, we have 9. Then you have minus 3 times -3. Shouldn't that be, what is that? What's -3 minus, or sorry, -3 times -3? Positive 9, so it'll be plus 9, right? Minus square root, what do we get over here? -10 times -3 is 30. 30 take away 12. Does this equal 0? What's the first square root? 18 minus square root of 30 minus 12? 18. What's square root of 18 minus square root of 18? It's 0. It works. Now you have to check -4, which I'm gonna skip. But if you plug in -4 and check it, it'll work also. All right. Now there's one more type that I want you to see before we call it a day. And it'll look something like this. Here we go. What is x minus the square root of 12x minus 11 equals 2? I want us to solve this. Whoa. Now this problem is the most complicated it's going to get today. Next class we'll have one more type, and it's going to be the worst one. But this is probably, if you look at all the problems that I've presented to you today, this is probably the type that you'll see on a test right here. It's not the hardest that you could get, but it's definitely not the easiest. It's kind of right in the middle. So let's see what happens here. What's our first step? Isolate. So you see your square root, right? It has a negative in front of it. See the negative that's in front of it? We normally, when we isolate our root, we don't want a negative in front. We want it to be positive. So what I would suggest in this one is to move that whole square root, the square root of 12x minus 11, to the right-hand side, which would make it positive, wouldn't it? And then take that 2 that's on the right side and move it to the left side. So let me see if I can do this all kind of in one step. I'm going to add this root to both sides. But then at the same time, I'm going to subtract 2 on both sides. So my 2's will cancel on the right side, and my roots will cancel on the left side. Okay, so it's x minus 2 equals what? 12x minus 11. Perfect. That's exactly what it is. And does everyone see what happened? Yep. Any questions on where I got that? Okay, second step, square both sides. So here I come with my parentheses. I'm going to square the left side. Here comes my parentheses. I'm going to square the right side. Now be extremely careful, everyone. Be extremely careful. Because the left side has to be squared, right? Which means you have to multiply x minus 2 times itself, which does not turn into x squared minus 4. Doesn't turn to x squared plus 4 either. You actually have to do x minus 2 times x minus 2, which means you have to FOIL it out. What about the right side? It's 12x minus 11, right? On the right side, it just cancels out. Okay, because you have the squared, you have the square root, they kill each other off, it's done. See, on the left side, you don't have that because you didn't have a square root, so nothing killed off. You had to square it. That's the biggest mistake I see right here. From here to here. Students will forget that on a test. And let's say this problem's worth 10 points on a test. If you go from x squared minus 2 squared on the left side, if you do not go to what I have here, and you accidentally write something like x squared minus 4 or maybe x squared plus 4, those are the most common mistakes I see from that, you're going to lose 8 points out of 10 right there. Because I'm telling you ahead of time, be careful for that specific instance. All right, let's FOIL that out. Here you have what? X times x is x squared x times negative 2 is negative 2x. The inside, negative 2x again. And the outside is positive 4. Equals 12x minus 11. So that's called foiling or expanding. And now let me collect some like terms together. I have x squared minus 4x plus 4 equals 12x minus 11. So all I did there was put these two terms together, negative 2x and negative 2x. All right, step 3. I will after I check step 3 real quick. Step 3 says if you have a square root again, repeat it, right? Repeat the process? Yeah, so I have no square root, so I'm going to go to step 4. And to do step 4, we're going to solve the equation, right? So I want to solve this, what type of equation? Quadratic again. So to solve a quadratic equation, we're going to move everything to one side of the equation and then factor or quadratic formula, whatever it may be. Minus 12x. Well, why don't you see that? How about we do this? You work on that, solving that equation right there while I take attendance. Okay, so everyone make sure you've got that last line written. I'll give you about 1 minute to write it down, start to work it, and I'll take attendance, and then I'll check to see if you got that answer, and I'll let you go. Anybody need it still? I'm about to get rid of it. I'll give you your homework in just a minute. The homework, page 547. You should do number 9, 13, 15, 17, 19, 25, and 33. All right, those are your homework problems.